Hi, hello everyone. This is Nepalidi sir from ANR Academy. Today I am here with you to discuss about how to draw the graphs of sin hx, cos hx, tan hx and cot hx, also secant hx, cosecant hx. That is, we are going to discuss how to draw the graphs of hyperbolic functions. First, I am going to draw the graph of y equal to sin hx. You know that y equal to sin hx, that is defined by e power x minus e power minus x whole divided by 2 for all x belongs to R. In general, to draw the graph of any given function, we have to substitute the values of x first. Corresponding outputs you have to write in a tabular form, and then after plotting the graph in the Cartesian coordinate system, you will get the entire graph of given function. See here what I am doing. First I am going to write the value of x equal to 0, and then I am writing 1, after that minus 1. First, when you put x value 0, then what is output? Observe, e power 0 1 minus e power 0 1 divided by 2, that become 0. So when you give input 0, output also 0. Next, if you give input 1, it become e power 1 minus e power minus 1, nothing but 1 by e whole divided by 2. This gives the positive result. Why? Because the value of e, we know that is Euler number. Here e is nothing but Euler number, and its value approximately 2.718. Substituting here 2.7 in place of e, the value of y become 2.7 minus 1 by 2.7 whole divided by 2 gives positive result. Next, substitute the value of x equal to minus 1. When you write x value minus 1, it become e power minus 1, that is 1 by e. Next, minus sign, e power minus of minus 1. So e power 1 divided by 2. Here, these two are of opposite sign outputs, so that the value of y become negative. And observe, as extending to infinity, what happens? Observe, e power x minus e power minus x by 2 is the function. You know that e power x graph, this is the graph of e power x. As extends to infinity, exponential function also approaches to infinity. This is 1 by e power x. So 1 by infinity divided by 2. So you will get large quantity divided by 2. That is, you will get infinite large quantity. Now I can draw the graph of sin hx. Clearly, the graph passing through the point origin 0, 0, 1 point here. Next, for x equal to 1, it gives positive quantity, so that I am going to plot the point above x-axis. Here, these two are of opposite sign and same quantity but opposite in the sense, so that here I am going to mention another point at x equal to minus 1. Output should be negative for x negative 1, right? Next, as extending to infinity, x values approaches to infinity, functional value also approaches to infinity. When it approaches to minus infinity, it also approaches to minus infinity, so that This one is the graph of sin hx. Next, we are going to draw the graph of cos hx. We can define cos hx as e power x plus e power minus x whole divided by for all real values of x. Again here e is nothing but Euler number approximately 2.718. Now put x equal to 0, x equal to 1, x equal to minus 1 and x value suppose infinity, what happens observe. Also as x tends to minus infinity, what is the function? Let us observe. By writing x value 0, y become e power 0 1, e power 0 again 1 divided by 2, that is 2 by 2 become 1. Next, suppose the value of x equal to 1, it is e plus 1 by e divided by 2. E plus 1 by e by 2, after substituting the value approximately 2.7 in this, it gives the result more than 1. 2.7 plus 1 by 2.7 whole divided by 2 gives the result more than 1. Next, in case if you write x value minus 1, what happens? E power minus 1, that is 1 by e plus e power minus of minus 1 e whole divided by 2. These two are same. So again more than 1. Next, as x tends to infinity, e power x plus e power minus x by 2 approaches to, here you know the graph of e power x, as extending to infinity, since it is rapidly increases, as extends to infinity it is infinity, plus e power minus x nothing but 1 by e power x. So 1 by e power infinity, 1 by infinity become 0 divided by 2. Infinite by 2, that is infinite, large numeral by 2. Here as x tends to minus infinity, also it approaches to infinite. Now draw the graph. Just these two interchanges, it gives the same result, like x equal to 1, x equal to minus 1. For positive and negative values of 1, it gives the same result. For positive and negative infinite, also it gives the same result. 0 comma 1, 0 comma 1 here. Next, 1 more than 1. When you put 1, it is more than 1. This is actually 1. More than 1 here. Also the same quantity, but same quantity for minus 1 also. So same height, you have to plot another point. Next, that approaches to infinite as extending to infinity. So it approaches to infinite. This is the graph of y equal to cos hx. Next, let us discuss the graph of tan hx. We know that tan hx, it is defined by sin hx divided by cos hx. Also you can write e power x minus e power minus x whole divided by e power x plus e power minus x. In the denominator part, sin hx is a fraction e power x minus e power minus x by 2. Cos hx also having in the denominator part number 2. Those denominator parts gets cancelled, you will get e power x minus e power minus x by e power x plus e power minus x. Now when you write x equal to 0, x equal to 1, x equal to minus 1 and x suppose approaching to infinity, what happens? Observe. When you write x value 0, functional value y become e power 0 value 1 minus e power 0 value 1, 1 minus 1, 0, 0 by something. It gives the result 0. Next, when you put x value 1, it is e minus 1 by e divided by e plus 1 by e. E minus 1 by e is less than e plus 1 by e. Denominator quantity is higher than the numerator quantity, so that it should be less than 1. Next, when you write x value minus 1, it is e power minus 1, 1 by e. Next, e divided by 1 by e plus e it is. Here, if you take negative sign common, the value of y become minus of e minus 1 by e divided by 1 by e plus e. These two are of opposite sign. Same quantity but opposite in the sign. Next, as x tends to infinity, what is e power x minus e power minus x divided by e power x plus e power minus x? Observe. Directly when you write the value of x infinity, you will get infinity by infinity model. Due to that reason, I am going to take common e power x. What happens when taking e power x common? 1 minus e power minus 2x it is, divided by e power x common 1 plus e power minus 2x. Limit extending to infinity. E power x gets cancelled. This is 1 minus 1 by e power 2x whole divided by 1 plus 1 by e power 2x. Limit x tending to infinity. As x tends to infinity, 1 by e power infinity, that is infinity, 1 by infinity, this portion becomes 0, 0. So that what we get? As x tends to infinity, functional value approaches to 1. Similarly, here these are of same quantities but opposite in the sign. So as x tends to minus infinity, I can say that functional value approaches to minus 1. Now draw the graph of tan hx. See here, maximum the value of y approaches to 1 as x tends to infinity. It starts from 0, 0, next positive quantity less than 1, and after that up to infinity if you go, it approaches to 1. First 0 comma 0, that is the graph passing through origin. When you write x equal to 1, y value positive. When you write x value 1, y quantity positive. Next, as x tends to infinity, it approaches to 1. X value suppose approaches to infinity, it approaches to 1. Next, x equal to minus 1 implies negative quantity. Somewhere here, negative quantity. And as x tends to minus infinity, it approaches to minus 1. You have minus 1 here. So this one is the graph of y equal to tan hx. Only it is defined in the interval. It is defined for all real values of x, and the range of the function only in the interval minus 1 to 1, remember. Next, you have to draw the graphs of cot hx, and then you have to draw the graph of secant hx, and then the graph of y equal to cosecant hx. You know that it is clearly reciprocal of tan hx, and this is 1 by cos hx. Here cosecant hx written as 1 by sin hx. So if you know the graphs of sin hx, cos hx, tan hx, then their reciprocals gives cosecant hx, secant hx and cot hx here. First we are going to draw the graph of y equal to cosecant hx. Let us discuss. With the help of sin hx, you can draw the graph of 1 by sin hx. Next, first draw the graph of cos hx and then go for transformation 1 by cos hx. Clearly that is secant hx. Next, tan hx first you have to draw and then go for transformation 1 by tan hx. See here, on Cartesian coordinate system, we know the graph of sin hx. With the help of this graph, now you have to draw the graph of their reciprocal. In the same way, you know the graph of cos hx. 1 to infinity its range, and defined for all x belongs to R. Next, tan hx defined for all x belongs to R, but it range from -1 to +1. Defined for all x belongs to R, but range is in between -1 to 1. Now observe the graphs of their reciprocals. Sin hx output 0 here, 1, suppose that is 2. Next here -1. Output values I am going to write -2. Here we have to transform from sin hx to reciprocal. Here when you transfer into 1 by sin hx, 0 reciprocal, that is infinity. Previous graph 0, now that changes to infinity. Reciprocal of 1, that is 1 again. Reciprocal of 2, that is 1 by 2. Next, in the first quadrant, let us draw the graph first. This shaded portion, that is white colored graph, indicates reciprocal graph. As extends to infinity, reciprocal goes to 0. So the graph decreases in this way. This is the graph in the first quadrant. Next, similarly, the same graph you will get in the third quadrant. This is the graph. So white colored graph in the first quadrant and third quadrant indicates reciprocal of sin hx, that is y equal to cosecant hx. Next, cos hx minimum value 1, suppose that is 2, both the sides will get 2, and then approaches to infinity. Now reciprocals of 1 reciprocal 1, here there is 2, 2 reciprocal 1 by 2, and approaches to infinity, the graph 1 reciprocal 1, 2 reciprocal 1 by 2. Next, infinity changes to 0. Joining all these points, we get the graph. See here, I am going to joining all the reciprocals now. This is the graph of 1 by cos hx, that is secant hx. Its range from 0 to 1, open 0, closed 1. Remember, the reciprocals of 1 to infinity gives the results open 0 to closed 1. Remember, in this figure, this clearly this is the graph of secant hx only in the interval 0 to 1 its range and defined for all x belongs to R. Next, we go for graph of cot hx now. Cot hx graph, that is reciprocal of tan hx, 0, 1 by 2, 1, minus 1 by 2, minus 1. 0 changes to infinity, 1 by 2 changes to 2, 1 changes to 1. So that in the first quadrant it decreases from minus infinite to 1 you will get. So this is the graph of reciprocal of tan hx in the first quadrant. In the same way, in the third quadrant, this is the graph. It indicates y equal to cot hx. This is about the graph of cot hx, secant hx and cosecant hx with the help of tan hx, cos hx and sin hx. First we have to draw the graph of sin hx, cos hx, tan hx, and just the outputs you have to mention in the graph. Their reciprocals gives the graph of cot hx, secant hx, cosecant hx. I hope you understand everything. The students, those who are appearing for entrance examination, they must concentrate on these graphs. Why? Because application questions may ask in continuity, differentiability, and in functions topic, particularly in domain and range. These are very helpful. So if you